I'd just like to document some of the issues I've been having with calibrating the Electrodacus SBMS for my shunts. So what we have here, this is a 50 amp 100 millivolt shunt for the solar panels. This is a 300 amp 100 millivolt shunt for the battery. Both are supposed to have an accuracy of 0.25%. The circuit breaker to the solar panels is off, as is my main switch over here, so there is no current whatsoever flowing to these shunts, except there will be through these two alligator clips hooked up to this power supply, which can act as a constant current source. So I'm just going to, here's the BMS. Okay, can you take this now and show the BMS? I'm going to just, reset it here so it goes through its initialization sequence in calibration with no power running through either shunt. And you can see here it's calibrating the ADC shunt. So the first thing that's a little bit mysterious is the fact that even though there's no power flowing, you can see that the battery value is bouncing around between negative 11 milliamps to positive 1 or even sometimes positive 7 milliamps. And this seems to be related to the current consumption of the BMS itself. For example, I found that turning on Wi-Fi will cause that number to more reliably go to a negative value, again, perhaps in the 20 milliamp range. Now, I'm about to add some power to those shunts via the power supply I have here, and I'm going to start with about 500 milliamps. Okay, it's actually settled on 498 milliamps. And we can see from this that the solar panel is calibrated just about perfectly, showing 497. But the battery is consistently reading 30 to 40 milliamps too high. And this is really where the crux of the problem is. So I'm going to increase the current to 5 amps running through the power supply. And again, we can see that the solar panel shunt is reading fairly accurately within about 0.1%. But the battery shunt is again on average reading 30 to 40 milliamps too high. And the concerning thing is there seems to be no way to adjust that offset. I mean, it's always too high. There's no way to adjust it. And it's showing a positive offset, even though when there's no current flowing, it was showing on average a drain. So here's one other mysterious property it has, which is that if I reduce the current flowing through the shunt to below about 260 milliamps, so here's 300, here's 290, 280, 270, 260, 250. And you'll notice that when I get below, let's see, 230, 220, yeah, when I get to 220, it starts randomly going between about 240, 250 milliamps, bouncing down to 0. I'll adjust it down a little bit further. I'm adjusting the current to, let's see, 180 milliamps. And you can now see that even though there is still 180 milliamps flowing through both shunts, which the solar panel shunt is showing, the battery shunt has gone back to only showing the current drain from the Electrodacus itself. It's not reflecting the current flowing through the battery shunt at all. So the combination of these two things, ignoring small current flows through the battery shunt, and second, having no way to adjust the offset of the battery shunt when higher currents are flowing, makes it quite difficult to calibrate this accurately.